experimental design today. Our last piece of chapter 1. We have, just like everything else in this chapter, definitions. Definitions and more definitions. So, experiments. We've kind of talked about the difference between an observational study and a designed experiment, so we have already touched on that. But when I talk about an experiment, remember that's just a controlled study conducted to determine the effect of varying one or more explanatory variables or factors. Okay, we have not seen that term factor before, and it does pop up, and even some homework questions are going to ask you to identify the factors. Those are the explanatory variables. Those are the things you are controlling. The response variable is what happens as a result of that. So maybe I am going to do an experiment, and I am going to see how giving you daily quizzes impacts your chapter test score. So, what would be the explanatory variables or the factors? The daily quizzes, the ones I'm giving you. What's the response variable? Your test scores. Okay, so the thing you manipulate, those are the factors or explanatory variables. The thing you measure is your response. The treatment is any combination of values of these factors. Maybe I'm going to decide, okay, this is a classroom, you guys are taking a quiz every day. You guys are not. We're going to take chapter tests at the end and see who did better. That's so, isn't it? So that's the treatment. You guys get this scenario, you guys get this scenario. And we're going to see what happens. Each of you would make up an experimental unit or subject in my experiment. So you are who I am applying the treatment to. Control group, that would be like this half the classroom. I'm doing nothing for you guys. You're just going to take the test and we're going to see what happens. You're my control group, you're my baseline. If they do better than you, then I can say, well, they did better than my control group, and my daily quizzes must have made a difference. Do you guys know what a placebo is?
Yeah, you give them like a thing.
Yes. A lot of medical studies, if they're trying to decide if a new medication works, they will give people a pill every day. And it may be the actual medication, it may be a placebo. Because a lot of times it's just a mental thing. You think you're getting medicine, so you think you're feeling better. And so in those medical trials, they use a lot of placebos to try to eliminate that factor and to see if there really is a significant difference. Okay, so in some of these scenarios, we can have what's called a single blind or a double blind experiment. So a single blind experiment would be when the subject doesn't know what treatment you're giving. So I'm going to do a trial. I'm going to give you guys vitamins to see if it makes you smarter. Okay. And some of you are going to get a real vitamin, some of you are going to get a placebo, a sugar pill. We're going to see. So if I know which one I gave you, but you don't, that's a single blind experiment. You're blind to what's really happening, but I'm not. I know. In a double blind experiment, neither one of us knows.
Okay, then how do they know at the end?
Well, they would have to have a file somewhere. So like, you know, if...
Well, that's because so she can't, like, do anything, like, say different wording.
Right, it's to keep me from messing with the effects. So there would probably be like a third person that is keeping a record, and then they give me the medicine cups each day and say, okay, this is for student A, B, C, D, E. They've got a list, they know which one it is, but me, the person running the experiment, I don't know, and you guys don't know what you're getting. We're both blind to it. And so that way that eliminates any impact I might have on the trial. Okay, so let's look at this. The English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, a faculty member randomly splits a section of her course. Half the students receive the traditional course and the other half is given an online version. At the end of the semester, both groups will be given a test to determine which performed better. Alright, so what's the experimental units? Students in the class. population for which this student or this study applies. Right. Basically, the freshman in the English course, right? Okay. What is the treatment? Okay, what is the response variable? Right, and we're doing that at the end with the test. So our test score would be our response variable. Okay, how come I can't do blinding with this?
Well, I mean, because they would know whether they're having online or traditional.
Right. You're gonna know if you're sitting in your dorm room taking your class online or if you're actually going to class and talking to your professor. And likewise, the teacher is going to know if they actually are teaching you or you're doing your work online. So both the student and instructor know which course is being taken. So there is no possibility of blinding in that scenario.
Yeah, this everything got restocked.
I feel like yesterday maybe I heard them out there.
I'm not even got rid of it. I'm not making it.
Alright, so, any questions about this example? Let's actually talk about designing experiments. This is not necessarily, I'm going to give you a quiz and say, tell me the 6 steps of designing an experiment. But this is kind of the guideline for what you have to do. You have to know the problem to be solved. It is pointless to try to develop an experiment if you don't know what your purpose is. So you have to know what you want to solve. Determine the factors. What's another name for factors? Explanatory variable that affect the response variable. Now, if I am trying to find a way to boost test scores, I have to be able to think about, well, what things might impact it. Those are going to be the things that I'm going to manipulate in my experiment. Determine the number of experimental units. What are the experimental units? You know, do I just want to test 10 students or do I want to test 100? Determine the level of each factor, control versus randomized. Okay, so we know, we decide which things we want to manipulate. Then I have to decide, how am I going to do that? Am I going to randomly select who gets what? Am I going to sit down and look at the list and decide who should get what? How do we go about that? Then you actually do your experiment, and at the very end you have to test your claim. You know, most of the time we talk about, is it feasible to do your experiment on everybody in the population? Not usually. So that's, remember, if I just described my result, that's descriptive statistics. If I want to draw some conclusion and apply it to a bigger group, that's inferential. And that's our main goal, is to get some good data that we could extend to a larger population at the end. Just another term that we're going to talk about, a couple different designs. The first is a completely randomized design. So everybody is randomly assigned a tree. Okay, I set my random number generator between one, let's say if I have 3 different things I'm going to try. I may have a control group and then the 3 different things I want to vary. So I just randomly use a random number generator or something to decide who gets what. So let's look at an example of that. create a randomized design and design this experiment. An engineer wants to know whether the level of octane in gasoline affects the gas mileage of an automobile. So let's design this experiment. What is step 1 in designing the experiment? Right. Step 1 was, that's not it. Identify the problem that we want to solve. So that is the very first thing I have to do. So what problem are we trying to solve? Mhm. Okay. What was step 2? Okay. So in this case, we're really, our overall goal is to look at gas mileage, right? So our factors, or the thing that we are manipulating, would be, what about the gas? The octane level in the gas. That's what we are going to manipulate. What other things might have an impact other than, okay, the type of car? Right. What kinds of things impact the gas mileage? Okay, driving style.
Where do you drive? In town or city?
Location. What about like engine size? Does that impact it? Okay, so is it as simple as just going out to the high school parking lot and giving each of you a sticker and say, okay, this is the octane level you're going to put in your car from now on?
You have to compare what it did before to what's not.
Right. There are a lot of other factors that can impact this. What do we call it? Do you remember when other things can impact your study? Confounding. Very good. What if there's something I didn't consider, like conditions, road conditions, driving in the ice versus driving on a nice sunny day. If I don't consider that, what's a variable that had an impact that we didn't think about? We had an actual name for it though. Talking about a lurking variable. That would be something if you failed to consider it, but it had an impact. That was a lurking variable. Okay, step 3. Determine the number of experimental units. So, I don't know what's going to be a good size. Let's just say,
Well, the diagram down here says 12 cars.
okay, I picked a diagram kind of. Suppose we choose 12 cars of same make,
The same
model,
breed.
year. Okay, that way we are eliminating some of these other variables by choosing the same type of car, same age, those things.
Should we put same location?
Yeah, that would be, like you could put in that, because could the location have an impact? We're going to get different gas mileage driving here than you would in St. Louis if you're waiting in traffic all day. So that would absolutely have an impact. Determine the level of each factor, control versus randomized. So the things that we talked about, the octane levels, we are going to vary those, right? So we will randomly assign people a variable. Engine size, we mentioned, that is fixed, because if we're picking all the same type car, we can assume they all have the same engine size, so I don't have to worry about that.
Driving style.
Driving style. So how would I control that so it wouldn't become,
I guess you could kind of put like one of those little things and monitor it.
okay, we could monitor it.
Have one person do it all.
Yeah. What if we just pick one person and that person's gonna go drive all 12 cars?
Okay, but like how I drive varies on the day.
Your level of road rage. So we would need to fix this in some way. Maybe having the same driver would work, or monitoring, or maybe taking them to
Oh, like
a
straight line.
racetrack and saying, okay, you are going to drive in this lane at a speed of this for this distance. Okay, so we could control that in some respects. Are there anything that we wouldn't really be able to control? So we talked about controlling the location. We could have weather. That would be an uncontrolled variable.
You can kind of control it, I guess. Like if you
Right.
pick like California, it's not gonna snow, but it's still gonna rain.
Right. We could maybe try to do them all. Say we're gonna pick a sunny day when it's 75 degrees out to do it. We can try to make it similar, but it's very difficult to completely control that variable. Okay.
Indoor racetrack.
Look
Very
at
well.
Look at that. It's
See,
controlled
thinking
now.
outside the box.
Like, if we were doing this on the test, if we explained ourselves.
Yeah.
Like,
And that's what a lot of this is. If you can explain what you're thinking, then there are different ways of approaching
we
it.
totally have completely different answers.
Yes.
How many of those like things do you want us to put like on color and stuff?
2 or 3, any obvious ones that you might think of. Alright, so how are we going to do this experiment? What do you guys think would be good? We have to vary the octane levels. So, how are we going to do that? Should we just say the first 3 cars that I see are going to get this octane level, and the next 3 cars are going to get this octane level? Or should we do it
Simple
random? Simple random? So, randomly assign them an octane level.
Okay, but shouldn't it like not matter if they're all the same like make, model, and year?
Right, it really shouldn't.
And
Unless
there's
there is
still
some
gonna be
other
different
variable we
wear
didn't
and
think
tear.
about.
There's different wear and tear on it.
Right.
Going by 2019.
Okay, but what about if this one had this on the line, someone dropped this part?
So how do we decide who's getting the best gas mileage? What would be a good way to do that?
Calculated.
Calculate it. So we're gonna
Or
fill
the
you
budget
up
tells you.
and you're going to,
We could drive a specific time amount.
okay, we could drive a specific time amount. What if we just put a specific amount of gas in and said drive until it's empty? Would that work?
Yeah.
Okay, so, let's say we give
5 miles in the tank.
5 gallons and tell them to drive it until empty. And we'll see who gets the first. Okay, and then step 6, the last one is our interpretation, so we just have to decide if there's a difference. The next slide I just put a diagram to kind of show how this could be done. We have 12 cars. Let's say we're comparing 3 different octane levels. We could put 4 cars at each level, and then at the end compare their mileage. So that would be something that works. Okay, that's completely randomized. The second type of design is a matched pairs design. Okay, in a matched pairs design, we pair up units that are somehow related. A good example of this would be like a before and after. We are going to teach a new fitness program in our PE classes, and we are going to gauge your level of fitness before this program and after this program. That's a matched pairs. they are doing the pre-U and the post-U. That is probably the most common type of MASH pairs. So, an example, xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. The researchers measured the children's ratings of the two types of milk. So, what is the response variable there?
The response to the non-cavities.
Well, we were trying to see what they thought of the taste, so we had them rate the milk. Think of some factors in the study, what's controlled and what's manipulated. So, controlled, these are things that may have an impact, but they're aware of it and they can try to control. What are things that might make a difference?
They're all Peruvian.
Okay, so we picked one nationality here. Do all children have the same things? Like, my 2-year-old and my 8-year-old have varying standards. Age is a big one. So they would want to pick children all of the same age, probably. Gender may have an impact. Location we talked about with the, and they kind of controlled that by picking all from one place. What's manipulated? What's the thing we're changing?
Xylitol.
Mm-hmm. So they either get it in their milk or not.
What if he doesn't like milk?
That would definitely have an impact.
You're not gonna like it regardless.
Okay, what are the treatments? The two options are milk with or without. So there are how many treatments then? Just 2 of this. What type of experimental design? So we are looking at one child and they drink the milk, they drink the milk with it, and then they decide what's better. What do you think?
Maybe match pair though, because it's like this is before, this is
Yeah.
after. Like this is with without without it.
Yeah, we could make that argument. Is there any blinding in this one, do you think?
Yeah.
Yeah, probably single or double, what do you think? Probably single. The researcher probably knows which one they're drinking, but the child doesn't. Okay, who are the experimental units?
Children.
Yep, the 75 children.
35 shadows.
Why would it be a good idea to randomly assign which one they drink first?
Because like, I don't know, I might like it the first time and like, I don't know.
I mean, kids are weird. Like, you could give them this and they're like, oh yeah, I like it. You give them the same thing 10 minutes later. Ew, that's gross.
If we are randomly assigning who gets what first, then that eliminates order as being an issue. Maybe they haven't had milk in a long time, and so the first drink of milk, they're like, oh, this is so good. So they always think the first one is the best because they haven't had it in so long, or something like that. So just by mixing that up, you eliminate order as an effect. Do you think it would be a good idea to double blind this? Would it be good so the researcher didn't know?
I mean, yeah. Because like they can say small cues that might
Okay.
to the kids that they could pick up on.
Yeah. You can make an argument either way, but that's a very good point. Maybe it's a good idea to double blind it so the researcher doesn't say anything or
Because they know
have a
it's better,
certain
so they wanna
expression.
push it.
Yes. So you don't want to accidentally influence the children in how you provide the milk. So yeah, it probably would be a good idea.
Like
to do
at the
that.
same time, I feel like that just involves an extra person.
That's true. So you would have to take in the practicality of doing that.
Yeah, I mean, like, at the same time, they're a bunch of kids, do they really care?
Right.
Are they really
Do they
gonna be,
care
like,
if they wanna
aware of everything?
Take the right milk or not?
Yeah, I don't think they really care. They just, like, they're gonna be honest, usually.
Yeah, if you're an honest opinion, ask a small child.
That's true. They get it to you. All right. So blocking is the third type of design. You group together similar experimental units and randomly assign each one to a treatment. If we randomize that, then each group randomly gets their treatment. Otherwise, you might be giving a certain group a certain treatment because you think it suits them better. Okay, so let's go back to our English department scenario. After some deliberation, they think that there might be a difference in the performance of the men and the women in the traditional versus online courses. So how could I change my experiment to measure the performance of online versus traditional and take into account the gender?
They can
Do the stratifier.
Okay, make it a
yeah,
stratifier.
break them into groups and make sure there's an equal amount of men and women in each class.
That's a very good idea. So we could break them into strata. You know, we have the men, we have the women. We randomly select the same number of men and women from each group to go to each type course. So that would be perfect.
So we'll just say stratifier.
Yeah, that would work. And the next diagram just kind of shows how that can be done. If we had 130 students, we could break them up into the men and the women, then separate each of those in half, and then look at our test scores from it. What questions do you guys have? So that is actually the end of what I have. So let's talk briefly. We do have a quiz tomorrow over chapter 1. So the things that we have talked about in chapter 1, we talked about quantitative versus qualitative, discrete versus continuous, sample versus population, statistic versus parameter, all of those terms, those were the big ones. We've talked about designed experiments versus observational studies. Observational study is when I don't manipulate anything, I can just sit back and see what happens. Yesterday we talked about, the different sampling techniques. Convenience, stratified, systematic, cluster, simple random. We talked about error and bias, sampling, response and non-response. We will do a little bit of review when you come to class tomorrow, so please bring all of your notes from the chapter with you to class tomorrow, and we are going to do some review the first half because it is not a very long quiz. So we'll start grading homework.
Are we gonna be on?
I might move on at the end.